So hi all, welcome to my YouTube channel CodeML, and this is part 2 for the machine learning project that is predicting customer churn. And in the part 1, we have covered this notebook till evaluating the percentage of the customers which were churned out, and what all the of the total of the customers are retaining the services with the company. So we have calculated from here. If I run this cell, so before that, I just want to tell you that if you are new to this, if you're viewing this lecture for the first time, there is an already introductory lecture for this, that is the part 1. I will suggest you first watch that lecture and then you come on to this video. Okay, so here I was talking about that we have evaluated, that is, we have calculated the percentage of the customers who have already opted out or churned out from the bank, or you can say any organization for which this data set is. Okay, so for our data set, 26.54% is the customers base who have opted out of the services from the bank, and 73.46% of the total customers are retained with the bank and are still the existing customers of the bank. Okay, so here this was just a basic data analysis which we have done, and now we will be actually doing the data cleansing, data wrangling, you can say data pre-processing. So we'll be actually doing the data pre-processing. So in the data pre-processing part, we check about, like, there are several steps which we do. So the first step is to handle the missing values. Okay, and then what we do is we are dropping the irrelevant columns. Okay, if any which which have a zero impact on our or the minimal impact on our predictor variable or the dependent variable, then for this particular data set will be, or for this like, it's a universal rule that the machine learning model will not work on the text data. That means here in the text data, as in I'm nowadays with the help of NLP we are doing a different thing, but here when I say our models, like regression and classification models, will not consider the text or the string data type. So for that, we convert those string columns to integers data type. Okay, and mostly you will be seeing this in this video itself, that mostly those columns which are categorical columns, we are changing using one hot encoding technique, sometimes label encoding technique we use to convert those categorical columns to integers. Okay, then we do a feature scaling if required. If you don't know this concept, I will explain in my future videos also that what is feature scaling. Okay, so you can see, and at this point of time you can read from the Google itself, there are ample of content available for feature scaling. Okay, and feature scaling means the column values, that is the feature variables, that is the independent variables, we need to scale the data, that is we need to, in comparison with other um, uh, columns and variables, you need to standardize, or you need to scale the data. So for that we use feature scaling, okay, for the data. Then the next step is train test split. Even this is also, like, sometimes considered as a in the process of data pre-processing. So that's why I have included the train test split also over here. So firstly, the first task over here which we have is handling the missing values. Okay, so handling missing values, firstly we'll check that how we check that whether the column, whether the data set have the missing values or not. So this is our data set, that is our DF. Then is null is the method which will check that whether in the data set, for all the rows, if the nulls are present, and this sum will actually tell that how many number of rows for that particular column have are missing or are null. Okay, so it actually gives the number of rows for a particular column which are null, or it's a missing data. Okay, altogether. So if I run this, okay, so you can see that for our data set as of now, we don't have any missing values. So this was our first insight, that there are no missing values in the data set. Okay, then we'll be going to, I have just listed out the column names. Why? Because sometimes it like this since Python is case sensitive, so that's why I have just listed down the column names. So you can list it down the column names for the data set using data frame dot columns dot values. So this will list out all the columns for you. Data frame dot columns dot values. Now coming on is that if we see the data set, if suppose if I show you the data set over here, I'm just commenting this, and just if we do a df dot head, so you can see customer ID, then gender, then senior citizen, tenure. See, these are all the columns. Okay, so in that, if I see customer ID, see customer ID will be a unique column for all the customers. Okay, and I don't think so, and even it's in a general practice, our employee ID or customer ID will not be helpful in predicting the dependent variable, whether that person, based on just his employee ID, we can't predict that whether this person will be churned out. That means he or she will be opting out for the service or will be retaining with the company. Okay, so that's why this is having a minimal or a zero impact on our dependent variable. That's why we have removed it. Okay, so for removing the or dropping the column, we have a drop method. Okay, so df dot drop, and then we are using we are writing the column name. That's why just for that's why what I did is just for checking the column names, I have just listed out this column so that the customer, and you can see ID is in capital letters. So exactly same column name I have written, and access equals to 1, and then data frame dot drop. See, it's a like good practice if you create a new data frame for manipulations. You just keep the original data frame which you loaded the data set, the original data set in a data frame. You should keep it as it is, because sometimes you may need to compare that, and you may create a different data frame altogether, and you can do all the manipulations over that. That's why I have created a new data frame, that is df underscore new, and with we will be proceeding with the all the changes, all the manipulations on this and under our df underscore new data frame. Okay, so I hope you are clear with this, and yes, you can see the customer ID, which was the first column, it has been dropped, and this is our new df underscore new data frame. Rest all the columns are there till churn. Just only the one column, that is customer ID, has been dropped. Axis equals to 1 means you are referring the columns. Axis equal to 0 means you are referring the rows. Okay, so now coming on to our next uh, a task, that is converting the categorical columns. Okay, so if I show you what all the categorical columns are, so even this for senior citizen, gender, see gender will have basically like three categories most often: male, female, and not to specify or others, you can see. Then here you can see dependents has no or yes, here also partner yes or no. So these are all categorical columns. So we have here, we have used a label encoder, and this is a very good library in our scikit-learn preprocessing module. So for that, we have just created a for loop, and we are iterating through all the like in our df underscore new data frame. And if that column, the data type is number, then it is just doing a continue. But if we have for else other data types, for why? Because see, we have only these data types. If I show you over here, 1 minute. Okay, my bad. Yeah, if I show you over here, okay, I don't think so. I have listed out that, no issues. What I will show you over here in this data set, see, you can see like monthly charges, total charges. Basically, mostly we have other categorical, other string columns are mostly the categorical columns. So that's why we have chose this for loop to do a transformation for all the other columns, all the non-numeric columns, and we have applied a label encoder over it. So what is the exactly how we do that? From that from sklearn.preprocessing, we have imported the label encoder. Then for I in df, this is just a simple syntax for loop. Df underscore new dot columns, it will create a like it will iterate to all the columns, how many columns are there. And then for each df underscore new, I will refer for the index I dot d type is equal to number. If it is number, then we will continue. And if it is other else data type, which we have only a string data type, then we are applying this label encoder directly dot fit transform. Okay, so and in fit transform, what is the value we are giving? We is df underscore new I, that means that column name. So we are just doing a fit transform with the help of this label encoder class. So this will exactly do the work for us, and it will change all these non-numeric columns like this, gender, partner, dependents, phone service. It will change to a numeric or a categorical numerical variable. I will show you over here. You can see as of now it has not changed, but if I run this first, okay, it has run. Now if I show you, so you can see now all there are no string columns as of now. These are all now changed to categorical columns. So you can see now gender 0 and 1. Okay, if you want to check for this new variable that what kind of value it has, so just you can do is value underscore counts. I believe this will work. And what I will do is I will just do this, and I will try to run and show you. So you can see for our gender dot value counts, it is giving us the two values, that is 1 and 0, and these are the numbers. For I think for male it has assigned 3555, and for female it has assigned 0, that is 3488. Okay, you can go ahead and check with that. Okay, now once our all the data set has been converted to a numerical category, that is the int data type, now we'll be doing a feature scaling. So for a feature scaling, you need to know that what is a standard scaler. If you don't know what is a standard scaler library, you need to go ahead and check that. Okay, standard scaler, what it does is it standardizes the data based on all the variables, all the feature columns. Okay, it will standardize basically the data. So standardize as in there is a particular formula for that. Okay, you need to check that. Why? Because see, these are the techniques which I can explain here on, but it will then lengthen up the lecture. So here you just for your understanding, you can just understand over here that standard it will standardize the data, and it will take it will calculate based on some formula. There's a formula, and on basis of that, it will yeah, actually all the columns values will be uh, standardized, and will be between -3 to 3. Okay, so the standard scaler does this using a formula. Okay, which you go ahead and check on Google. There is a formula, and if you want, I can provide this in the description as well. Okay, so we have imported the standard scaler from our scikit-learn preprocessing library. We have created a standard scaler object for this sc is equal to using this standard scaler class. And then what we have done is, see, for our all the independent variables, see, I can write over here all this. These are all independent variables other than churn. Why? Because churn is our only dependent variable. Okay, so for our X data frame, what we have done is we have dropped the churn column and X is equals to 1. And for our dependent variable, we have kept the churn column into our Y variable, that is a Y data frame. Okay. Okay. So here what we are doing is what we have done sc.fit transform. Sc.fit transform means we are using this a standard scalar object, and we are applying a fit transform method with the help of this object over our X data frame. Okay, and if we do this, okay, and yes, if I show you as of now what will be the values, so it will come as an array. Yes, you can see, and these values will be in the range of -3 to +3. Okay, so standard scalar will fit in the data, all the data as ever, how much huge the data is, it will fix in the data between the range of -3 to 3, so that all the variables are not having a huge impact on each other. Okay, so this is the change which we brought in our data set with the help of the standard scaler. Okay, so I hope you are clear. Similarly for y also, if you want to check, you can check. See, we don't need any kind of transformation for our y, for our y variable. Why? Because it is already in the range of 0, like -3 to 3. So that's why we have not standardized the data, and there is no point in standardizing the dependent variable. That's why we have kept the data for the y variable as it is. Okay, now coming on to our next task, that is train test split. For train test split, we have done is uh, we've imported a train test split module from our scikit-learn model selection package, and we have taken the 90% data as a training size, and we have specified the test size as 0.10. So this is the see, these are the lines of code which you will be writing in almost all your machine learning projects. Okay, so so we have done this x train x test, y train y test, and then this is the train test split class. And in this, our first parameter will be the x data frame, which will be having the independent variables, then our dependent variable. Then this is the test size parameter. Here, see, the best percentage of the data which you can keep for the test size, or if for the training size, if I say, mostly for our machine learning models, not less than 75% of the data which we keep for training. Okay, and even mostly we keep the data for our training is 80%. So that means the test size would be 20%, or you can say here 0.2. But here for training the model, I have kept, you can keep any value and you can check the accuracy and you can evaluate. Here I have kept the test size as a 0.1, that is 10% of the data for testing purpose and 90% for training our model. And random state is equals to 0 means all the time, every time our and the model will pick the rows with the random state equals to 0. So it will be the same every time. That's why I've kept the random state equals to 0. Okay, now coming on to building and training our model. Okay, so building and training our model, I have selected the classification model, that is the logistic regression model. Why? Because it is more like it is the simplest one of all, and it is most commonly used. It's not like that it's the most commonly used. I thought to implement the logistic regression classification model, you can even use decision tree, or even you can use svm, or k nearest neighbors, whatever you think. Okay, it's not, sorry, my bad, not knn, but you can use svm decision tree random forest for this classification problem as well, and you can evaluate on your own the accuracy. Okay, so here from our linear underscore model package under sklearn, I have imported the logistic regression. Now this is the class object for our logistic regression, and we have fitted the data, that is our training data, x underscore train and y underscore train, with the help of this class object of logistic regression. And if I do this, okay, okay, why? Because I have not run this, that's why it is showing x train is not defined. Okay, now it has defined. Now if I run this, you can see it has the data for the x training, our model has been trained. Okay, and now I will be making the predictions on our test data set. So see, y underscore pred is our new variable, and we have a x underscore test data. So y underscore pred is actually the are predictions on the X test data. Though we already have a Y underscore test, which are actual data for these X underscore test records, but we have our predictions based on this our logistic regression object. So cls.predict is the method which helps in predicting the like from our model on the testing data set. So I have just printed this, and you can see these are 0 1s combinations, that which all the like sixth or seventh, this is sixth record, sixth customer has been churned out, and then like that eighth customer is also churned out. So now it comes out to a last part where we are going to evaluate our model. And here with the help of for regression problems, we have different parameters to evaluate our model, like um, uh, root mean square error parameter, then mean square error parameter, and even we have uh, R, R square, adjusted R square, are few parameters which we use for evaluating our regression model. Similarly, we have like a scores like precision, recall, and F1 scores, and which helps in evaluating our classification models. Okay, so here I have used one such, and I am importing the classification underscore report library from our scikit-learn metrics package. Here you can see that from sklearn.metrics import classification reports, and I'm just printing the classification report. So classification reports takes two parameters. First is the actual one, that is y underscore test, that is the actual values for our x underscore test independent variables, and y underscore pred will be the predictions which we have got over here, these. So if I run this, so it will calculate our the precision, recall, and F1 scores. And here if you see for 0 the precision is 0.83, for 1 it is 0.61, and these are the like scores, precision, recall, and F1 scores. And here if I show you the accuracy of our model, we have 79% of the data we have predicted accurately, and hence we can say that by fine-tuning different parameters over here, if we train the data with some different data set, if we tune the parameters over here, might be we get the accuracy, a more improved accuracy over here, might be 80 to 85%, it can be improved. And based on different models with the different algorithms, like SVM, or if you say uh, decision tree or random forest, might be you will be getting a good better accuracy. So I think that you can try to practice and implement on your own. And this completes our predicting customer churn dataset project. And we have you are seeing that we have achieved a 79% accuracy. And actually this is a good accuracy for the starting, for the persons, those who have started their machine learning career and to learn machine learning. Okay, so I hope you are clear with this project, and if you have some of the doubts, please comment in this video, and I will be happy to resolve them. And I have already pasted the code, this notebook link, in my part 1 video, and I will be also pasting the same thing in this video as well. So please hit like, share, and subscribe my channel. And my next video will be on customer segmentation project. Okay, so that is a unsupervised learning project. So please subscribe my channel, and do let me know for any positive or negative feedbacks. Thank you.